What's up, guys? We're going to look at the method for titration now. Previous video having looked at the method for standard solution, right? So we've made our standard solution. We've got a known concentration there. And generally this is either going to be an acid or a base. And we're going to do a neutralization reaction with an acid or a base of unknown concentration, right? So say we might have made HCl down there and we're using NaOH to titrate it against, okay? So it's that sort of thing. Now, generally speaking, what we're going to do is we're going to fill our burettes with the standard solution from our conical flask, okay? What we're then going to do is we're going to take our unknown sample and we're going to use one of these. So this is just a pipette. And there we can take out our fixed 25 centimetres cubed of our unknown solution. We're going to put that into a conical flask. And then we're going to add some sort of indicator. That can be phenolphthalein, it can be methyl orange. Next it comes to our burette, where we actually come to do our titration. So first thing we've got to do, we need to think about rinsing our burette. First with water. And then with our solution. Our solution that we're putting in the burette in the first place. And that's so there's no dilution. Therefore, there will be no dilution. We've got to do a few things before making sure it's ready. We need to make sure that the tap is filled. Because our reading on our burette also includes this tap. So oftentimes if this tap has been shut and it's been filled, we've taken our starter reading, we've done our titration, but a load of our mixture has just been used to fill up this tap here. So we need to make sure that this tap is filled. And we do a few safety things. We make sure we're not pouring above eye level. We might have to move that down, etc., etc. But then once we're ready to go, we put our conical flask under and we start our titration. So we do our titration in such a way that, first of all, we're going to do our rough titration. So we know roughly how much it's going to take. And then we're going to start doing our finer ones. Once we move on to those, we're looking to get final drop, leading to a colour change. And not only that, we're then going to do repeats until we get what we call concordant results. And there, that's going to be plus or minus 0.01 centimetres cubed. So our values need to be very, very, not 0.01, 0.1 within that of each other. So let's take a look at the sort of table we're going to be doing. First of all, we need to make sure that all of our values are to 2 decimal places. But that is with a provision. And the provision there is our final digit is either going to be a 0 or a 5. And that is because the readings we have on our burette are all like to 0.1. So if we're halfway between, say, 0.1 and 0.2, we're going to call it 0.15. If we're closer to the 0.1, we'll call it 0.10. If we're closer to the 0.2, 0.20. So it's that kind of thing, right? The burette's not precise enough for us to say 0.12 or 13. It's always going to be a 0 or a 5. So we take our initial readings before, and again, like with the standard solution, we're looking at where the bottom of the meniscus touches. We're looking there. So we do our initial reading, we do our titration, and then once we see the indicator has changed, we do our final reading and subtract those. We look at the difference to work out what our actual titer is, okay? We do not use our rough. Our rough is just that, it's our rough, right? So at this point, we know we can do it very quickly up to about 20 centimetres cubed, and then we need to start going slower so that on our final drop, we can see that change in colour. A few things to notice here as well. Even when I do my subtraction here, often people get into that habit of writing 22.8. That won't be good enough. We'll need to keep it to 2 decimal places. So it's still 22.80, 0.80, 0.10. Okay, we're always going to ensure we have 2 decimal places, or we can lose our results there. So we don't use the rough, but then we do look for concordant results. So the concordant results again are within plus minus 0.1 centimetres cubed of each other. So we ignore the rough. These are the same, and this is a little bit too far out. So then, when we're working out what our actual titer is, we add our 2 values up, and we divide them by the number of groups. We use our average. So here, obviously, that's going to be 22.80 centimetres cubed. And then we'll look at, in the next video, as to how we use that within our calculation. Hope that helps. Happy revising.